The material inside every Boeing 787, every wind turbine blade, every future flying taxi. And most companies making it have destroyed more money than they've made. In this episode, we'll answer 3 questions. First, why is carbon fiber so expensive that even the world's largest producer barely breaks even? Second, who actually controls this $7 billion industry? And third, 3 massive demand waves are hitting at once. Can they finally fix the economics? Carbon fiber starts as polyacrylonitrile (PAN), a white polymer thread thinner than a human hair. You heat it to over 1,500 degrees Celsius in an oxygen-free furnace. What comes out is a black filament that's 10 times stronger than steel at 1/5 the weight. But here's the problem. Only 45 to 50% of that PAN actually converts into usable fiber. More than half your raw material burns away in the process. The PAN precursor alone accounts for over half the total production cost. And then you weave thousands of filaments into sheets, layer them with resin, and cure them under pressure to create composite parts. The result is extraordinary, a material Boeing trusts to hold together a 250-ton aircraft at 40,000 feet. But the process is brutal on margins. Energy intensive, low yield, and capital heavy. And that's before we get to the real cost killer, the one that keeps most of this industry trapped. If you want to sell carbon fiber to Boeing or Airbus, you don't just need a great product. You need 7 to 10 years of qualification testing under FAA and EASA oversight. Every new fiber grade, every new application, every new production line tested, certified, documented. This is why aerospace-grade carbon fiber sells for $150 to $200 per kilogram, while industrial-grade fiber crashed to just $12 per kilogram in late 2024. Same material. Same chemistry. 12 times the price. Because of a certification moat that's nearly impossible to cross. Chinese producers added 25,000 tons of new capacity by 2026, flooding the industrial market. Prices collapsed. But aerospace grades? Stable. Protected. Locked in by a decade of paperwork. This 2-tier pricing creates a brutal industry structure. Companies serving aerospace can earn double-digit margins. Everyone else fights over scraps. Let's look at who's actually profitable and who's bleeding. Hexcel, the largest American carbon fiber composites maker, posted $1.9 billion in revenue in 2024. With a 12.4% adjusted operating margin. Their secret? 80% aerospace exposure. Boeing and Airbus together represent 55% of their sales. TRYIY, the Japanese giant controlling roughly 30% of global carbon fiber capacity, finally turned its CF segments solidly profitable. 22.5 billion yen in operating income, up 71% year over year. But it took decades of patient investment and a post-COVID aerospace recovery to get there. Now look at the other side. THJEY took 40 billion yen in impairment charges on its carbon fiber assets. And is pulling out of North American composites entirely. SGL Carbon's revenue dropped 17% in 2025, they're reviewing site closures. TPIC Composites, the world's largest independent wind blade manufacturer, lost $210 million. And Carbon Revolution, a carbon fiber wheel startup, went bankrupt in March 2026. In carbon fiber, you're either in aerospace or you're in trouble. Here's the global picture as of 2026. 3 Japanese companies, TORAY, THJEY, and Mitsubishi Chemical, control roughly 60 to 65% of aerospace-grade carbon fiber supply. TORAY alone holds 30% of global capacity and is expanding 3 sites simultaneously: South Carolina, France, and Korea. Mitsubishi Chemical is doubling high-end capacity at plants in Japan and California through 2027. Billion-dollar bets on demand that hasn't fully arrived. Hexcel dominates the American aerospace composites market with a 12% margin. And a customer book locked in by decades of qualification. SGL Carbon, the main European player, is in survival mode. Revenue down 17%, restructuring underway. The critical nuance: not all carbon fiber is the same. Aerospace uses small toe, high-performance fiber. Wind uses large toe, cost-optimized fiber. Different products, different factories, different economics. And China's largest producers, Zhongfu Shenying, Guangwei Composites, are scaling fast but listed on domestic exchanges only. No ADR access. For global portfolios, the investable universe is 5 to 6 companies. That's it. A single Boeing 787 Dreamliner contains 23 tons of carbon fiber. 50% of its airframe by weight. The Airbus A350 is even higher at 53%. And the upcoming Boeing 777X will feature the largest composite wingspan ever built. Nearly 72 meters tip to tip. Boeing is ramping 787 production from 7 to 10 per month. Airbus targets a 350 output of 12 per month by 2028. Aerospace consumed roughly 68,000 tons of carbon fiber in 2025, 43% of total global demand. This is the industry's cash cow. Aerospace buyers pay over $150 per kilogram, sign multi-year contracts, and qualify incredibly slowly. Meaning once you're in, you're locked in for decades. Hexcel has been Boeing's composite supplier since the 787's first flight in 2009. That relationship isn't going anywhere. Now here's where volume explodes. A wind turbine blade longer than 45 meters needs carbon fiber in its structural spar. Carbon fiber is 4 times stiffer and 40% lighter than fiberglass per unit weight. Beyond 80 meters, a fiberglass spar simply can't support itself. Today's offshore blades routinely exceed 100 meters. Carbon fiber isn't optional, it's mandatory. Wind energy is actually overtaking aerospace on a pure tonnage basis. The carbon fiber wind blade market is growing at over 15% annually. Vestas, the world's largest turbine maker, hit record revenue of $21.3 billion in 2025. But here's the tension, at $12 to $15 per kilogram. Suppliers are selling commodity product into a price-sensitive market. TPI Composites makes the blades but lost $210 million doing it. Volume without margin, that's wind energy's bargain with carbon fiber. The third wave is smaller today, but the unit economics are completely different. Joby Aviation's S4 air taxi is 85% carbon fiber by structure. TRYIY signed a long-term supply deal. Joby flew its first FAA-conforming aircraft in March 2026. Targeting 500 units per year and commercial launch in Dubai by late 2026. Archer Aviation has a $6 billion order backlog. Then there's hydrogen storage. A Type 4 hydrogen tank requires roughly 10 kilograms of carbon fiber. For every single kilogram of hydrogen stored, one fuel cell car needs 56 to 72 kilograms of carbon fiber just for the tank. And carbon fiber is over 50% of the tank's total cost. If the fuel cell vehicle market reaches 5 million units by 2030, hydrogen tanks alone could require 170,000 to 250,000 tons of carbon fiber annually. More than today's entire global production. That is a demand wall. So here's the real question, can 3 demand waves fix the economics? There's a bear case worth taking seriously. Wind energy wants the cheapest fiber possible, it doesn't lift pricing power. eVTOL is still pre-revenue, Joby has burned through nearly $1 billion in 1 year alone. And hydrogen fuel cell vehicles keep losing the cost per mile race to battery EVs. Maybe the tipping point is a mirage. And carbon fiber stays trapped in the same low margin, high capex cycle it's been in for 30 years. But here's what the bear case misses. All 3 waves hit the same finite supply base. New capacity takes 3 to 5 years to build. Qualification for aerospace applications takes even longer. And the suppliers aren't adding enough. TRYIY, Mitsubishi, and Hexcel are expanding. But their combined new capacity covers maybe 1 demand wave, not 3 converging at once. TRYIY and Jilin Chemical Fiber already announced 10 to 20% price hikes effective January 2026. The commodity price collapse of late 2024 may already be reversing. In my view, carbon fiber is approaching an inflection point. Not because any single demand wave is a game changer, but because 3 mediocre growth stories, stacked on top of each other against rigid supply, create a squeeze. The companies that survive this transition will define the next decade of advanced manufacturing. Looking ahead 12 to 18 months, the most likely path is supply tightening with gradual price recovery. I'd put roughly a 60% probability on aerospace-grade prices holding above $150 per kilogram, while industrial grades recover toward $18 to $22. Watch these 3 signals. First, Boeing 787 production rate. Every step from 7 to 10 per month adds roughly 800 tons of annual carbon fiber demand. Second, offshore wind blade lengths. Every major turbine maker moving beyond 100 meters is a structural demand lock-in for carbon fiber. Third, Joby Aviation's FAA certification timeline. Commercial launch in late 2026 would be the first real proof point for eVTOL carbon fiber volumes. On the upside, a European mandate for Type 4 hydrogen tanks or accelerated 777X certification could tighten supply faster. On the downside, another Boeing production freeze or deeper Chinese industrial overcapacity could extend the pricing pain. Upstream, pan-precursor suppliers and specialty chemical makers gain leverage as demand rises. Downstream, aerospace OEMs and wind developers face higher composite input costs. A theme worth watching across the entire advanced materials space. That's carbon fiber, a material stronger than steel, lighter than aluminum, and harder to profit from than almost anything on Earth. The few companies that survive the cost paradox are sitting on one of the most important supply chains of the next decade. I'm Big Z, follow me, see you in the next deep dive.